In our first video on vectors, we talked a little bit about how you can find a direction angle pretty simply. We had this basic formula set up for tangent inverse of your vertical component divided by your horizontal component. So kind of like y over x is the way to think about it. This was going to be our theta. It'll also be important to remember that theta is always going to be measured. So let's say this is our vector here. Theta will be measured from the positive x-axis counterclockwise. But the idea that I want to kind of push here and want to be careful about is going to be the fact that tangent can be a little bit frustrating for a lot of people because calculators don't always give you the answer you're looking for. For example, many calculators will give you negative answers for certain values that you get, but a negative angle would mean that you're swinging clockwise. So what I want to do is very quickly just point out that if I had a vector v with the components 5, negative 3, and I had a vector, let's say w, with components of negative 5, positive 3, these would be drawn in different directions. So for example here, vector v, we have a positive x, so we have a positive x, we have a negative y, and so our resultant vector would be something like this. So I tend to think about that as sort of a fourth quadrant vector because it's pointing in that direction. But over here, we have 1, 2, 3, 4, 5 in the negative x direction, and we have 3 in the positive y direction. So this is something that would actually end up in our equivalent of the second quadrant. For this one, our theta, if we're going with the traditional definition of counterclockwise from the positive x-axis, would spin all the way around here. This would be a massive angle. And then for here, we're going to have a little tiny theta right here. Well, notice though that although these thetas are very different, if I were to put theta equals tangent inverse of negative 3 over 5 for v, wouldn't w also be the same? Because look here, we have a positive 3 divided by a negative 5, that's still just negative 3/5. Although these two angles that we're wanting to get here are very different, the input into the calculator is exactly the same. Even if we differentiate it, let's go ahead and take a look and see what happens if we do this. And also keep in mind that you should definitely make sure you're in degree mode. If I go in here and I say second tangent or inverse tangent of negative 3 divided by 5, we're going to get about negative 31 degrees. So let me go ahead and write this down. Maybe I'll write this down as theta prime because obviously something's wrong here. And then over here on the right, I'll just demonstrate this just to show it. If I had put that in as 3 divided by negative 5, notice it's really the same thing, and the calculator reads it the same way. So we'll just call it theta prime again. Slide this out of the way. I would look at this and go, well, first of all, both of these problems, while I've done them correctly, I've set them up physically correctly, both of them gave me the same wrong answer. The reason for this is the calculator doesn't know. It sort of works with the easiest angle to get to. It found the closest, the smallest value in terms of magnitude for theta to get to here. And so what you need to do is be able to adjust for this. One thing that can be kind of focused on here is that tangent has a period of pi, or 180 degrees. The reason that that's important and useful is because of this very reason here. When you alternate the signs on your x's and y's, you end up with the same tangent results. So on the unit circle, for example, if you've studied that a bit, let's find a spot up here that I can kind of scribble. If we had these two things that are directly opposite each other, which is what's happening here with our 5, -3 and our -5, 3, the distance here is 180 degrees. The same thing is true here. This would be 180 degrees. So when they go in and they give us that negative value, the negative value is this angle here. This is the theta prime that we just came up with. Well, if I want to find this little guy here from earlier, this guy here, well, I could just add 180 degrees to get there. The idea is that halfway around the circle, halfway around this path, it's going to give me the result that I'm looking for. It's going to give me another angle that's going to have the same setup here. Let's see what happens with this one. This one's a little easier to visualize. Let's see what happens if we add 180 to this. Let's do theta prime plus 180. So theta prime plus 180. So in this case, I still have it in my calculator actually, so let's go ahead and just do that there. We get 149 approximately 149 degrees. Now that's an angle between 90 and 180, and we set up here that we'd expect this to be in the second quadrant. So I go down here and I go, well look, that's 149 degrees. That's between that 90 and 180, that's that second quadrant. This would actually be my theta for this particular vector, for vector W. That's obviously not the same angle as this over here though. This angle spins past 90, past 180, past 270. This is somewhere between 270 and 360. So adding 180 once would not be enough. So we can add 180 again, or really effectively, we can add 360. Let's add 360 to this, and we're going to find that theta is actually going to be equal to 329 degrees. Now when I look at this, I go, okay, 329 degrees, that's somewhere between 270 and 360, but it still gets that same general setup, the same result of the 5 and the -3 here. And so here we go. We found our thetas for both of these examples here. I'll put together a couple other videos with just single examples for some extra ones to look at, but this is going to be the general idea of what you're going to have to watch out for. We're going to see that in the first quadrant, things work out really nicely because the calculator understands if I did tangent of, say, 3/5 instead, if it's something in the first quadrant with positive, positive, it gives me an angle where it belongs. But if I do, let's say, tangent inverse of -3 divided by -5, so that's something that would be in the third quadrant, it still gives me that first quadrant angle. So in that situation, we would also have to add 180. So it seems here that in general, closing up, if you have a first quadrant problem, so something that has positive, positive, so maybe I should say positive, positive, then you will have to make no adjustments. If you have a second quadrant problem, this is something where you have a negative x value but a positive y value, you're going to see that you likely have to add 180 degrees to your theta. Let's call it theta prime. If you're given something in the third quadrant, this will be the same way. You're going to have negative, negative. This one was what we just saw, would also need 180. And the most annoying one, most likely, I almost wrote that as quadrant 4 in the wrong way. Look at me not using numerals correctly. Quadrant 4 has positive followed by a negative, and this one you're likely going to have to add 360 degrees to your theta prime. So these are adjustments that you will have to make.